Hello everyone and welcome. Today I would like to talk about reorder list. The solution to this question is based on three easy linked list techniques, including finding the middle, reversing, and splicing. But together they are able to form a more complicated order like this question. So let's take a look at it. Specifically, this question gives you the head of a singly linked list, asks you to reorder the list as the following, and asks you just to rewire their connections but not modifying the values in the listed nodes. As mentioned, this question is actually testing your ability to leverage and combine previously learned techniques to solve a median level difficulty question like this. Those techniques are relatively easy by themselves, including middle of the linked list, reversing linked list, and merging two sorted lists. If you are not familiar with those techniques, please feel free to look up those videos in my channel first. To solve this question, we will use three steps. Step 1, we'll find the middle in the linked list. For example, the node 4 here. Step 2, we'll reverse the linked list starting from the middle of the linked list. So 6, 5, 4 here. Step 3, we will splicing or merging two linked lists. So 1, 2, 3 is one list here, and to be spliced with this 6, 5, 4 as in here. By performing these three steps in order, we are able to approach this question systematically. With the background introduced, now let's write the code. So we're going to remind ourselves the three steps. Step 1, find the middle. Step 2, reverse the second part of the linked list from the middle node. Step 3, merging the first part of the linked list with the reversed linked list from the second part. Okay, so that's our three steps. So let's implement them one by one. So step 1, find the middle node. One way to do this is to have a fast and a mid pointing to be the head first. And while fast and fast next exist, we move mid to the mid next, and fast move to the fast next. And by the end of this while loop, mid will be the middle node, pointing to the middle node. Next, we're going to perform step 2, reverse the second part of the linked list from the middle node. So we will have the temp and previous point to mid and none first. And while temp next is assigned to be previous, and previous is now becoming temp, and temp will be becoming temp next. And by the end of this while loop, we have the new head equals to previous. Okay. Step 3, we're going to merge the first part of the linked list with a reverse linked list from the second part. So by the end of step 2, we have this one equal to head and this 2 equal to the new head. Let's take a look what happened to this 1 and this 2 in some examples. So if the original list is like 1, 2, 3, by the end of step 2, we have this 1 equals to 1, 2, and this 2 equal to 3 and 2, and this 2 is the mid. Okay, and none. Okay, now if the original this is like 1, 2, 3, 4, by the end of step 2 we'll have this 1 like this, 1, 2, 3, 3 is the mid, and this 2 will be 4, 3, again 3 is the mid, and then you can see that this 1 is sorry, this 2 is either same length or 1 node shorter than this 1. Okay, so this is critical here, and they also how they share the mid as the last element. Okay, so with this inside, we're going to do a while loop while these two next exist, and we will be performing this one next equal to this 2, and this 1 will be this 1 next. This simultaneous assignment is important because this 1 next or this 1 will change, and so if you have then in a separate line, that it wouldn't work. Okay, and this 2 next. Similarly, we have this 2 like this. Okay, and then we'll be able to merge the two lists through this process. Okay, and that's our code for this question. Now let's submit it to see how it works. We submit and done. So let's take a look. It passed the test. Very good. So finally, we can analyze the code for complexity. So you can see there are 3 while loops here. While fast, while temp, and while these 2 dot next. Each of them is on time complexity. So the overall time complexity is on, and for space complexity, since we only use constant space variable here and do the rewiring, so it's O1. Okay, and that's all for this video. I hope you find this video to be useful. Please subscribe for more videos if you like, and I hope to see you next time soon. Goodbye.